Today we're going to be working with lesson 3.3. So let's take a look at some notes. So we have discrete and continuous. We also have our vocab right here, so make sure you take a look at your vocab sheet for the definition of each of these words. So a discrete function, our points are not connected, so we just have points kind of all over the place. A continuous function where the points are all connected so they form a line or a curve. And then neither discrete nor continuous is kind of a mixture of both. They're not one solid line, but they're not just random points kind of all over the place. The second key concept we have is what's known as standard form. So that's when we have an equation in the form of ax plus by equals c, where a, b, and c are all integers and a is greater than 0. So some examples of this would be 2x plus 5y equals 7. Here a is 2, b is 5, and c is 7. So let's take a look at the first example. So example number 1. We want to determine if this is going to be a discrete or a continuous. So if we look at this, we're dealing with number of books and a price. So since we can't have a fraction of a book, this is actually going to be a discrete function. So this will be a discrete function. And again, that's because we can't have 1.75 of a book. So let's take a look at example 2. Example says determine if this is a continuous or a discrete or neither. So let's take a look at the first one, A. So if we notice, this is a nice curve that comes down, goes back up, and then goes down and keeps going. So this will be a continuous function. And the reason for that is because it is connected at all points. It makes a nice curve. Over here, g of x, well, we have this point that kind of makes a line, so making a point. So this is going to be neither. And the reason why this is going to be neither, because it has sections of continuous and sections of discrete. So since it has both sections and it's not folding one of those, it is neither. All right, let's take a look at example 3. We want to apply discrete and continuous function. So we charge 25 per hour for any amount of time up to 8 hours. Then it's a flat rate of $250 per day. So we want to take a look at this graph and determine, is this a discrete, continuous, or neither? And if we look here, it looks like it's going to be discrete until this little point down here, where we have starting at 0 coming up to 250 is a continuous function. So this will be neither again. First part or section is continuous. And then second half so second part is discrete. So that means that it's going to be neither, and this is the reasoning behind it. So this next part we're getting into, example 4, this is dealing with that ax plus by equals c idea. So we want to determine whether y equals 4x squared minus 2x squared plus 3x minus 5 is an equation of a linear or nonlinear. If it comes in this form, then it will be linear. So let's work out this problem. So what we're going to do is we're going to start off with squaring this. So I have y equals 4x squared. So 2x squared gives me, again, 4x squared plus 3x minus 5. How did I get that second? Because that's going to be 2x times 2x. 2 times 2 is 4. X times x is x squared. That's how I got that second 4x squared. Well, I noticed 4x squared and 4x squared are opposites of each other, so that just leaves me with 0. So I'm left with 3x minus 5. Now what I want to do is try to get it into this form of ax plus by equals c. So to get it in this form, I'm going to move this over to the other side. So I'm going to subtract 3x from both sides. That gives me negative 3x plus y equals negative 5. So that is pretty much of that form, because a equals negative 3, b equals 1, and c equals negative 5. So this would be a linear function. Now, let's try example 5. So for example 5, I want to simplify the function as well. So I have y equals 3x squared minus x to the third. Oh, sorry, this is x to the third. This is x to the third plus 3x plus 6. So I notice that I have the same power here, so that means these are like terms. So 3x to the third minus x to the third gives me 2x to the third. So it gives me y equals negative 2x to the third plus 3x plus 6. So now I've simplified as much as I can. Now I want to try to get in the form of ax plus by equals c. So I'm going to start off with adding 2x to the third to both sides, which gives me 2x to the third plus y equals 3x plus 6. Now I'm going to bring that 3x to the other side. So I'll put it between. Running out of space, so I'll bring this up here. So that gives me 2x to the third minus 3x plus y equals 6. So I have my a is negative 3. I have my b is 1. And I have my c is 6. But I still have this 2 here that can't fit into that idea, that key concept. So this is going to be nonlinear. And this is the reason why. Because that 2x to the third makes it so it's nonlinear. So example 6, functions in table. So what we want to do is we want to take a look at this. Is this a function that models the height of a ball, a linear or a nonlinear function? So if we start looking at this, we have time, 0, 0 0.5, 1, 1.5, 2, 2.5, 3, and 3.5. So during the first half and the second intervals, the ball goes from the height of 2 all the way up to a height of 58. So the first half, it's going from 2 all the way up to 58. That's an increase, or sorry, from this to here, it goes from 2 to 28, so that's an increase of 26, and then it goes from 26 to 48, and then from 48 to 56, and then from 56 to 2. So you notice this is a jump of 26, while over here we have a jump of 2. And then from 28 to 46, we have a jump of 18. Then we have a jump of 10. So if we look at these jumps, we notice that the jumps are not the same. And because the jumps are not the same, this is nonlinear. Now let's take a look at this one. We're using a garden hose to fill an empty pool. The table shows the amount of water that's being added every 5 minutes. So the jump from our first to our second is 60. From our second to our third is 60. Third to fourth is 60. And fourth to fifth is 60. So each jump here is the same. So that means we have a linear function. Where in example 6, they weren't the same. That's why it was a nonlinear function. So in this section, we covered looking at discrete, continuous, and neither. So if it was a full curve, then it was continuous. If it just had points, then it was discrete. Then we worked with identifying linear and nonlinear. If it fell in the form of ax plus by equals c, then it was linear. If it did not fall in that form, then it was nonlinear. Then we looked at it in tables, where if the change on the tables was the same, we had a linear function. If the change was different, it was nonlinear. So go ahead and summarize this up right here and use these notes to help you answer the practice problems.